When you're implementing a hash table, collisions are inevitable. And what a collision is when two distinct items have the same hash value. So what ends up happening then is those items will be assigned to the same index in the hash table. And that's a problem, because if you already have an item in the hash table and another item needs to go there, what do? You can't just reject it, because the consumer of the hash table, the end user, it shouldn't know that you had a collision. It should be a totally transparent thing. We're going to look at two common strategies for dealing with collisions. The first is called open addressing. And what open addressing does is it says, all right, you've gone to index 3, there's already something there, so let's go check index 4. Is there anything there? Let's put you there if there's not. And chaining actually has a linked list. And it says, all right, you need to go in index 3. Well, there's already something there. So let's make a linked list and have the existing item and this new item both be in it at index 3. Let's take a more in-depth look at those. So open addressing. So we have an item Jane already in the hash table. And we want to add the item Steve to the hash table. So we go through our add algorithm. We get the hash code for Steve. We find the index. And what we discover is that Steve and Jane collide. So what we're going to do is say, while the array index is not null, move it forward. So we're at this next array index. It is null, so we're going to break out of the while, and then we're going to assign Steve into that index. But think about what this means. We didn't put Steve where the hash code said Steve should be. So next time we come looking for Steve, we need to take that into account. Chaining works somewhat similar in that we start with a user in the table and we want to add Steve. We perform the start of our add algorithm. But what we do now is, instead of saying, is there a conflict? Rather, we just add the user to the existing linked list. We don't know if there's a conflict. The linked list could be empty, could have 10 things in it, could have 100 things in it. We don't know. Chaining allows us to not think about that. And what's nice about chaining, as opposed to open addressing, is that later on when we come looking for Steve, all we have to do is find the index and now find out, is Steve in the linked list?